Multiplexing and demultiplexing are two most important functions of transport layer. Multiplexing refers to the process of collecting data from multiple sources and to make them ready for further processing. On the other hand, the demultiplexing is the reverse process of multiplexing, where data from multiple sources are separated into individual components for further processing. Multiplexing occurs in the source, whereas demultiplexing occurs in the destination. Or in the other words, the multiplexing is performed when a host sends request, whereas the demultiplexing is performed when a source receives the reply. To illustrate the concept with respect to the given example here, the host S connected to three different applications, or in host S, three sources are generating data. The transport layer collects data from all the three applications and it adds the respective port number and send it to the next level of processing. This addition of this port number to the data segment, it enables the host to identify the different data which is generated from different applications. So once the port layer or port level address is added to the data packet, then it is ready for processing by the other layers. Again, when reply receives by source from different destinations, the transport layer reads the port number and determines which application is requested this received data. For example, if any data which is coming from the D1, this is the D1 identified, say port number P99 for example, then this packet will carry port number D90, P90, P99. So this P99, by looking at this port number, the source will deliver that packet to the respective application, in this case which is Facebook. That way the source can demultiplex. This is called demultiplex, demultiplexing the data packet. While we talk about multiplexing and demultiplexing, there is a very important point to be explained or point to be discussed. The multiplexing, also known as mux, and demultiplexing, demux, happens in a computer network layered architecture in two different layers. One, it is in transport layer that we have discussed, which we have discussed here, and another multiplexing is carried out in the physical layer. In the transport layer, multiplexing and demultiplexing is enabled in terms of packets or segments, or in the physical layer, the multiplexing and demultiplexing is done in the signal level. This one we have discussed in the transport layer, as we have seen just now, and the physical layer multiplexing will be discussed in the physical layer, or when we will discuss the data link layer part of this course. Now let us understand how it happens in the physical layer, how multiplexing and demultiplexing takes place in the physical layer. Suppose that this is one source S1, this is one source S1, this is one source S2, this is one source S3. These are three sources, and they generate data, and this data is transmitted to the network through some intermediate routers. And suppose that all the three sources are connected to the router R1. This R1 is connected to another router R2, and this line is only the transmission line which is connecting R1 and R2. If we consider in the signal level, S1 will generate one signal, say this type of signal, and similar identical signals will be produced by S2, and that one also will be produced by S3. That means all the three sources will produce signals of similar pattern. Now when it comes to this router has to accumulate all the three signals, and it has to pass through it. If R1 passes all the signals together and they are in the same phase and they are in the same frequency, then it is difficult for the receiving side to differentiate these signals or identify these signals individually. So as this result, this signal which is generated from R1 in the original form is not sufficient to transfer over the network, because it will not be able to recognize in the destination side. That is why what R will do, when the R1 receives data from S1, so this is the signal, this signal will be added with a signal of some different type, then it will produce one resultant signal who will have a different structure than the original form. Similarly, the signal from S2, it is the same form, but it will be added to some different signal of this type, say, and it will produce another signal like this, another type of signal. That way, that will be done for S3 also. So finally, it will integrate all these three signals and will produce one signal which is completely different from the original signal, like this, somewhat like this. And this is called multiplexing in the signal level. This is multiplexing in the signal level. Similarly, in the receiver side, what it will do, the receiver will take the composite signal. This is called composite signal. It will fit to a component which is called demultiplexer, and it will generate different signals, S1, S2, S3. And this S1, S2, S3 will have the same original form as it was being communicated. So this process of multiplexing and demultiplexing, which takes place in the physical layer, is performed in the signal level, whereas the multiplexing and demultiplexing, which is performed in the transport layer, takes place in the packet level. It is a very important concept, and you should remember this point while we talk about multiplexing and demultiplexing.